Hey guys, I was just wanting to do this. I know we kind of went over it with you in class, but I do want to go over it again just in case somebody is having problems. So our work today was to go over this momentum and impulse in the textbook. Okay? And so what we were supposed to do is the first thing we needed to do is we needed to make a one-pager. Well, when we are going through, it's giving us some information on like what the momentum is. So that's momentum equals mass times velocity. And it also gives us some information. So here's my one pager is what I did. Okay, so on this one, I was talking about the soccer ball and how the soccer ball, when you're hitting it with your foot, it changes the speed and the direction of it. And then also, depending on the linear motion of the mass of velocity, it has the product of the mass and the velocity. So here what they did is they did a small p, which is momentum, is mass times velocity. And if we were looking for momentum dimensions, that would be mass times lead time divided by time, which is kilograms. And that's also going to be times meters per second seconds. There's no square on it. And then they gave us an example of a bicycle and how that bicycle was going downhill. And as it's going downhill, it has a hard time to stop. It also talked about if you went bowling with a bowling ball compared to a playground ball, how you could actually have it knock the pins down, but it would take a more time and more force. So it gave you a problem here. And that sample problem was an ostrich with a mass of 146 kilograms running with momentum of 2,400 kilograms per meter. To the right, what is the velocity of the ostrich? So the only thing you had to do there is just take your mass and you have your P. And then what you're going to do there is you're going to go through, and that's momentum, remember, mass and momentum. And then we're going to change this equation to get what we need. This equation is what it is, and this is what we're changing it to. So the first thing that it's talking about is it's talking about a deer. And that's on page 193. So this is it right here. So it says that, it says that a deer, right, has a mass of 146 kilograms, running head-on toward its speed at 17 meters per second, is going north. Find the momentum of the deer. So the only thing you had to do here is just write out your variables, change your equation, and just do the math. It's pretty straight math today, so it's not really hard, but I will show you anyway. Open bracket, so if we're doing this, 146 times, open bracket, 17, close bracket, and we're going to get this number here. But do you know it's different because this is in scientific notation? So to be able to do that, you just change your mode to scientific notation, and you do second enter, and then there we are, 2.482 times 10 to the third power, which I'm just changing it to 2.5 because I'm rounding it up. Okay, so number 2 talks about a 21 kilogram child, 5.9 bike. So this here is the child, this is the bike, right? And it tells us the velocity of 45 meters per second to the northwest. There we are. So the first thing it asks us for is it asks us for the total momentum of the child and the bike together. So the only thing we had to do here is we're trying to find the total mass, right? So we're just going to add them together, and that's 27 and 4.5. That's our velocity, right? And that's going to give us our 1.2 times 10 to the second power. So what we did here is we took our mass total and times our velocity. Once you add those two together, you're going to get this number. And then I just multiplied it separately. Now, if you put it in your calculator, the only thing you have to do is open bracket 21 plus 5.9, close bracket, open bracket 4.5, close bracket, and that's going to give us 1.2 times 10 to the second power, which is in northwest because that's the way it was traveling. Now, B is asking us for the momentum of the child, so we're only looking for the child here. Here we're asking for the bike. We're just using the bike here. Remember, bike and child. Then number 3 says a blue whale has this mass of 1.46 times 10 to the 5th kilogram. The momentum is 9.73 times 10 to the 5th kilogram, and it's going south. So one thing we're doing here is we're just taking our numbers, our P, and divided by our M to get that number. So the next thing we're going to do is we just turn the page, and it's the change in momentum. So when we're talking about changing the momentum, it takes force and time. So based on that information there, we actually have the impulse theory. And the impulse theory is probably the most important thing that's on this sheet here. And as you can see here, they're just breaking it down into different things on what it should look like. Besides that, and on my one-pager, I just went through and I just wrote down the impulse theory. I wrote down that small force, long time, long force over short time, they both have the same momentum. And then what I did there is I went to the sample problem, which is right here. And then I just wrote down the variables. I drew my directions so I could know if it's positive or negative. Remember, this right here, if you've got a highlighter, I would highlight it in my book. And remember, you're putting this all in your book now, which is the composition book that I have, so that'll be good. And then what you're just going to do here is you're just going to do exactly what it's doing there, and you're just going to get your answer, and it should be 7.0 times 10 to the 4th newtons. Okay? Now, if you're putting this in the calculator, what you're going to do is you're going to do your alpha y enter. You're going to do your open bracket 1400 close bracket, open bracket 0 close bracket, subtract, open bracket 1400 close bracket, open bracket negative 15 close bracket. Then you're going to go down, and then you're going to put your point 30 in here, and you're going to hit your enter key. Look what I got. 7 times 10 to the 4th power. No problem at all. So let's go ahead and let's look at the practice problems that are on the bottom on page 195. So, just like we had before, you're just taking your football is thrown at a velocity of 15 meters. The stationary receiver catches the ball at rest, and then he is bringing it, the change in time for it was 0.20 seconds, and it's asking you what the force of the ball is. So what you're just doing here is you're just doing the same thing you did up there, no problem. Number 2, 82 kilogram man drops from rest at a diving board at 3.0 above the surface, okay, and the water comes at rest at 0.55 seconds until he reaches the water. What is the net force of the diver as he is brought to rest? So for this one here, you have to use this formula, which is a little bit different than what you've seen before. Make sure you've wrote that down. So if we are doing that right here, which is the square root, so what we're going to do is going to do alpha, which is the blue button. We're going to find the square root button, which is right here. Okay, and we're going to do 2 open bracket 9.81 close bracket open bracket negative 3.0 close bracket, and that gives us that answer. Sorry guys, which trying to turn it off. So if I look at here, why did it not do it? So enter. Let's try again. We change this. So second square root 2 open bracket 9.81 close bracket open bracket negative 30 close bracket enter. It's still giving me an error. So, since I'm getting an error, this is what I'm going to do. I'm going to do 2 times 9.81, close bracket, open bracket, negative 3.0, close bracket, and I'm going to get an answer. Okay? Then what I'm going to do is I'm going to do second square root, and then second answer, and hit enter. It's a non-real number. Wow. So maybe what I need to do here, maybe I just need to do just the whole number. So let's see. Second square root. I have 2, open bracket, 9.81, close bracket, open bracket, 3.0, close bracket. Guess what? I finally get a number. So, what I'm going to do here is, remember, it could be positive or negative. So since it can be positive or negative, we're going to look and see what direction it's going in. Well, it's a negative direction, so here's the number. And then we're doing time of the man in the water. So his velocity 1 is this number, and he's going downward. That's why it's a negative number. Our velocity final is 0 meters per second. And now what we're trying to do now is we're trying to find the net force of the diver that is brought to rest. So we're going to do mass velocity final minus mass velocity initial over the change in time. And then what we're going to do is we're just going to plug that into our calculator so that we can actually see it. And so with that one there, we're just going to do our alpha y enter. We're going to do open bracket 82, close bracket, open bracket 0.0, close bracket, subtract, open bracket 82, close bracket, open bracket, negatives 7.7, close bracket, and then we're going to go down 0.55, and that gives me 1.148 times 10 to the third, which I changed to 1.1 times 10 to the third. And then number 3, which is our last problem of the day, what we're going to do here is how I did it, and if you need to pause this to look at it, you can. And I'm going to say this is it for today. Today I have a NASA shirt on, so I want to let you know that I will be seeing you in the morning. We have set a time up to meet, and if you can come, that's great. We're going to talk. If you have any questions, let me know. And I will be getting to your test hopefully later on today, and I'll be releasing it to you hopefully by in the morning. I hope you're having a great day, and I'll see you tomorrow.